The direwolf. Just its name evokes images of a creature straight out of our wildest imaginations. The direwolf, or Canis dirus, was one of the most formidable predators of the Pleistocene epoch. Its name, meaning fearsome dog, is a testament to its reputation as a top predator. Larger than any wolf alive today, the direwolf roamed North America until its extinction around 13,000 years ago. These magnificent creatures were significantly larger than the modern grey wolf, weighing up to 150 pounds and standing nearly 3 feet tall at the shoulder. They hunted in packs, much like today's wolves, but their prey included megafauna, such as mammoths and giant ground sloths. Imagine a wolf standing as tall as your hip, with teeth powerful enough to crush bone. The direwolf's massive jaws and strong teeth were perfectly adapted for taking down large prey and scavenging carcasses. Their robust build and powerful limbs made them excellent hunters in the harsh environments of the Ice Age. This formidable predator was a force to be reckoned with. Their social structure and pack behavior allowed them to coordinate attacks and take down animals much larger than themselves. The direwolf's presence in the ecosystem was crucial, as they helped control the populations of large herbivores and maintain the balance of their environment. But what if I told you that scientists are on the verge of bringing back the direwolf from extinction? Advances in genetic engineering and cloning technology have opened up the possibility of de-extincting this incredible species. By studying ancient DNA and using modern techniques, researchers hope to resurrect the direwolf and reintroduce it into the wild. This groundbreaking work could not only bring back a piece of our planet's history, but also help restore ecosystems that have been disrupted by the loss of apex predators. De-extinction, simply put, is the process of bringing extinct species back to life. It sounds like something out of a science fiction film, but thanks to incredible advances in genetics and biotechnology, it is rapidly becoming a reality. By extracting ancient DNA from fossils and utilizing cutting-edge gene editing techniques, scientists are piecing together the blueprints of life itself. Imagine a future where creatures we thought lost forever could once again roam the Earth. The direwolf, scientifically known as, was a dominant predator during the late Pleistocene epoch. These powerful hunters roamed alongside iconic Ice Age animals like mammoths and saber-toothed cats. Fossil evidence tells us that they were social animals, much like wolves today, living and hunting in packs. Their disappearance, along with many other megafauna, marked a significant shift in Earth's ecosystems. Now their story is on the verge of a new chapter. The de-extinction process begins with finding well-preserved DNA samples from the extinct animal. This is often the most challenging part, as the DNA must be sufficiently intact to be useful. Scientists scour various locations, from ancient tar pits to frozen permafrost, in search of these precious genetic materials. Each discovery is a small victory, bringing us one step closer to the possibility of bringing an extinct species back to life. In the case of the direwolf, scientists have extracted DNA from bones and teeth preserved in permafrost and tar pits. These environments act as natural time capsules, preserving the genetic material for thousands of years. The DNA extracted from these sources is often fragmented, but it provides a crucial starting point for the de-extinction process. Each fragment is meticulously analyzed and catalogued, forming the building blocks of the direwolf's genetic blueprint. This genetic material, though fragmented, holds the key to reconstructing the direwolf's genome. Advanced DNA sequencing technologies allow scientists to piece together these fragments, much like assembling a complex jigsaw puzzle. Each piece of the puzzle brings us closer to a complete picture of the direwolf's genetic code. This reconstructed genome serves as a template for the next stage of the de-extinction process. Using a closely related species like the grey wolf as a template, scientists can then use gene editing tools to cut and paste direwolf genes into the living species genome. This process, known as CRISPR, allows for precise modifications at the molecular level. By inserting the direwolf genes into the grey wolf's genome, scientists aim to recreate the extinct species' characteristics. This method leverages the similarities between the two species, making the genetic modifications more feasible. This process, still in its early stages, is incredibly complex and requires meticulous precision. Each step must be carefully monitored to ensure the accuracy and viability of the genetic modifications. The ultimate goal is to create a living, breathing direwolf, but this is a long and arduous journey. The science of de-extinction is not just about bringing back a single species. It holds the potential to restore entire ecosystems and reverse some of the damage caused by human activity. As we continue to refine these techniques, we move closer to a future where the line between extinction and existence becomes increasingly blurred. Section 5. Challenges on the path to resurrection. De-extinction is not without its hurdles. Finding intact DNA from extinct creatures is a major challenge. The older the genetic material, the more degraded it becomes. Additionally, even if scientists successfully reconstruct a complete direwolf genome, bringing it to life presents another layer of complexity. It may involve using cloning techniques or manipulating the reproductive cells of a closely related species. Section 6. The dire wolf's place in a modern world. The prospect of reintroducing the dire wolf to modern ecosystems is both exciting and daunting. This ancient predator, which roamed North America during the Pleistocene epoch, has long been a subject of fascination for scientists and the public alike. With advancements in genetic technology, the idea of bringing back the dire wolf is no longer confined to the realm of science fiction. However, the implications of such an endeavor are vast and complex. Some scientists believe that bringing back extinct species could help restore balance to damaged ecosystems. The dire wolf, with its powerful build and hunting prowess, could potentially control overpopulated prey species, thereby promoting biodiversity. In theory, this could lead to healthier forests and grasslands, as well as more stable ecosystems overall. The concept of rewilding with apex predators has already shown promise in other contexts, such as the reintroduction of wolves to Yellowstone National Park. The direwolf, as an apex predator, could play a role in regulating prey populations. Its presence could help curb the numbers of herbivores that, if left unchecked, might overgraze and degrade habitats. This natural regulation could foster a more balanced and resilient ecosystem. However, the dire wolf's hunting habits and territorial behavior would need to be carefully studied and understood before any reintroduction could be considered. However, introducing a large carnivore into a world drastically different from the one it last knew is not without risks. Modern landscapes are fragmented by urban development, agriculture, and infrastructure, creating challenges for large predators that require vast territories. Human-wildlife conflicts could become a significant issue, as dire wolves might come into contact with livestock or even people. The ethical and logistical challenges of such a reintroduction are immense. We must carefully consider the potential impact on existing species and ecosystems. The introduction of a new apex predator could have unforeseen consequences, potentially disrupting current ecological balances. Thorough research, extensive planning, and cautious implementation would be essential to ensure that the reintroduction of the dire wolf, if pursued, would be beneficial rather than detrimental. The decision to bring back this iconic species must be made with a deep understanding of both the science and the ethics involved. Section 7. Ethical considerations. Playing God or righting past wrongs. The idea of de-extinction raises profound ethical questions. Are we playing God by bringing back extinct creatures? Is it ethical to manipulate the genetic makeup of living species to recreate ones that are gone? Some argue that our focus and resources should be directed towards conserving the incredible biodiversity that still exists. Others believe that de-extinction offers a chance to right past wrongs and restore ecosystems that have suffered from human activity. Section 8. A future with direwolves? While the possibility of encountering a direwolf in the wild may seem like a distant reality, the science of de-extinction is advancing rapidly. It is not a question of if, but when we will have the capability to bring back extinct species. What that future will look like remains to be seen. Will we see dire wolves roaming national parks, their howls echoing through the night? Only time will tell. Section 9. Conclusion. A testament to human ingenuity. The quest to bring back the dire wolf is a testament to human ingenuity and our fascination with the natural world. It compels us to confront ethical dilemmas and ponder our responsibility to the planet. Whether or not we ultimately see dire wolves resurrected, the journey itself is pushing the boundaries of science and forcing us to re-examine our place in the grand tapestry of life.